Hello everyone. In this section, we will talk about microbial identification. After learning this section, you should be able to outline the methods of identification of the microorganisms. There are so many microorganisms in the world, and some of them look remarkably similar. So, it is important to identify them from each other. Usually, the classical methods and the modern methods were used. First, the classical methods of classification and identification. Traditionally, the morphological, physiological, biochemical, and ecological characteristics were used in identification. Look at this table. It shows some morphology features used in classification and identification, such as cell shape, cell size, colonial morphology, ultrastructural characteristics, cilia, endospore shape and location, spore morphology and location, and so on. Among them, most features can identify all major groups, including bacteria, archaea, fungi, and protists, but some features just can be used in identify some type of organisms. For example, endospore shape and location. It is just used in identification of some gram-positive bacteria. Look at the next table. This table shows the physiological and metabolic characteristics used in classification and identification. For example, carbon and nitrogen sources, cell wall, energy sources, fermentation products, general nutritional type, motility, growth temperature range, oxygen relationship, salt requirement, storage inclusion, and so on. Second, the modern methods of classification and identification. The modern methods of classification and identification were mostly based on molecular characteristics. Firstly, the nucleic acid base comparison, especially the G plus C content. It can be determined by determination of the melting temperature. It is taxonomically useful because variation within a genus is usually less than 10%, but variation between genera is quite variable, ranging from 25% to 80%. Secondly, nucleic acid hybridization. It determines the degree of sequence homology. Thirdly, the nucleic acid sequencing. The small subunit RNAs are almost ideal for studies of microbial evolution, relatedness, and genus identification, because they contain both evolutionarily stable and evolutionarily variable sequences, and they play the same role in all microorganisms. So, it can be used in identification and deeply understanding the phylogenetic relationships. A phylogenetic tree can be built using RNA sequences. First of all, the 16S RNA sequences of microorganisms could be sequenced or retrieved from GenBank. Look at this picture. It shows the information of the RNA sequences in GenBank. The first file can be downloaded. Then, all the sequences should be edited by some softwares. For example, the lysogen. And then they can be aligned and adjusted with softwares. For example, Cluster and Edit Plus. Finally, Phylogenetic Tree was built using some methods, such as maximum parsimony, base, and so on. Look at this picture. It is a phylogenetic tree of some microorganisms. Finally, complete bacterial genomes have been sequenced. It undoubtedly will become an important method in taxonomy and identification in the future. This is a word list for you. That's all. Thank you.